Let me explain how these work. So, in this picture, all right, I have my main polynomial and I have its two factors on the side. So if I actually drew a line here, all right, so if I actually drew some lines, this is kind of what it would look like. All right. So the way you figure out algebra tiles is you're literally just it's a counting game. So how many x's do you have? How many x squares do you have? How many ones do you have? So if I wanted to count this side right here, what do you think this would be? How many x's do I have? Ones. This would be x plus how many ones do I have? 3. So this side represents x plus 3. This side also represents x plus 3. Now, the middle would be their product if you multiply them together. So it's like almost like a big box method. So this would be what it's like with the box. And so essentially what they're doing is they're doing area. Because area of a rectangle is just length times width. Well, the length of these two bars are x. So the long side of the x bar is x. Well, x times x is x squared. The length of each side of this one is 1, and the short side of the x bar is 1. So x times 1 is x. And so that's how they keep doing it. It's like a big box method. All right. Now, if you add up everything that's on the inside, what would the polynomial be? So how many x squareds do I have? 1. So we have x squared plus how many x's? 3. No. 5. Total in this entire picture right here. Oh, 6. There's 6 x's. And how many ones? 9. All right. And for example, if we actually did that box method, so x plus 3 on top, x plus 3 on the side, this would be x squared, 3x, 3x, 9, still give us x squared plus 6x plus 9. So it actually works. All right. Now, this is actually a square. So it's not just a rectangle, it's a square. Why do you think it's a square? So why do you think this shape right here in the middle is a square? What's true about a square? 4 sides. Well, no, duh. All 4 sides are equal. Well, what's the length of this side? 3. Oh, x plus 3. X plus 3. What's the length of this side? X plus 3. What's the length of this side? This side. So all 4 sides are congruent. They're all x plus 3. So we actually have a square here. All right. And that's what it's going to mean by completing a square. We're going to actually make squares. All right. So on your end, let's do the first one kind of together. So the first thing is that we want to arrange the algebra tiles so that it looks like a square, or as best as we can get it to look like a square. So if we look at my example here, you want to take your x values or your x bars and split them evenly between the side of the x squared and the bottom of the x squared. So there's 4 x's here. So how many think I'm going to put on each side? 1. There's 4. 2 on each. Because we want 2 to the side. And then we can turn these 90 degrees and 2 on the bottom. If you look, they actually attach pretty nicely. So they should lock into place automatically. All right. Now, let's take a guess. How many ones do you think I'd be able to fit here? 6. Oh, 3. So I would think about 4 because we wanted to fit just in this space, and that's just to complete the square. So I'm going to take all of my ones and fit them as best I can. So I have 1, 2, 3, 4. But then I still have 4 left over. So I'm just going to add those off to the side. All right, so how many ones do we have left over? The answer to that is 4. Because in reality, to complete the square, we only need these 4 ones to complete the square, and these 4 on the outside that don't line up with anything, they're just kind of on their own. All right. All right, so try the second one. So this time we're trying to figure out how many we need to add. So first off, how many X bars would I have on each side? 3. So there's 6 divided by 2, we get 3. So we have 3 here. Then you can turn these. And then we have 3 here. Now, we only have 2 ones, but how many do you think we're going to end up having to have? 9. Why do you think 9? Right, we're trying to make a little square, so 3 times 3 is 9. There's 3 bars on each side. So how many do you think we're going to have to add? 7. All right, so if we added the 7, which if you look over to the side, just click algebra and then algebra tiles, and then you can just drag and drop. Okay. So you just drag and drop them.
And I already finished this part.
Okay, you're fine. And then we would have our square. Now, I'm going to put the 2 ones over here because that's what we originally started with, just so we remember. So how many do we need to actually add in reality? 7. So here we had to add 7. Now, let me explain to you how completing the square works. All right, so I'm going to move these out for just a second. I'm going to put my 2's here. All right. So let's look back at our first one. So whenever you want to complete the square, we're going to imagine, I'm going to draw a line. We're going to imagine that this line represents an equal. So first off, given what I have currently in this picture, what would my quadratic expression be? So how many x squareds do I have? So it'd be x squared plus 4x plus 8. We have 8 ones. And it's currently equal to 0. All right. Now, here's the deal when it comes to completing the square. We want to make room for the square itself. So what we're going to do is, in order to make room, I want to remove all the ones we currently have. So I'm going to take all of these ones, and I'm going to move them to the other side. Now, mathematically speaking, if I move anything around the equal sign, what do I have to do to it? Change the sign. So I'm just going to hit negate. So in other words, I subtracted 8 to both sides. So now I have x squared plus 4x, and I'm going to leave a big space to represent I need to fill it with whatever I need to add. I'm going to set it equal to -8. Now, how many squares did I have to put in here to fill? No, to complete the square. So in order to make a perfect square, 4. So I'm going to drag and drop 4 squares in here. Now, how do you know it's 4? Well, no, duh, but how do you understand that's 4? So you're essentially making a 2 by 2 square. So in other words, since we had 2 x's here, 2 x's here, 2 times 2 is 4. All right, so in other words, we took our b value, divided by 2, because that's how many are on each side, and then we multiplied it by that number or squared it. All right, so in other words, b over 2 all squared. Now, here's the kicker. whatever we add to one side. So if we add 4 here, what do you think we're going to have to do the other side to keep it balanced? Add 4. So watch this. So I'm going to duplicate this, drag it over here, and I'm going to put it on top of 4 of my ones. And what happened? What happened to 4 of my negative ones when I dropped those positive ones on top of them? They disappeared. They became 0. So how many do I have left? -4. So now I got x squared plus 4x plus 4 is equal to -4. Now, the last thing I want to do is I want to break this down into my side lengths of my square. So now that I have my square, I want to know what the side of each square is. So if this is area, so we're talking area, this represents the area of the square in here. What would one of the side lengths be? So in order to get x squared, what would I have to multiply together? So think box method. In order to get x squared, what 2 values would I have to multiply together? X times x. In order to get 4 ones, what 2 values would I have to multiply together? Nope. And also get 2 x's here and 2 x's here. What's the square root of 4? 2. So this would be 2 and 2, which we can also see as this is the length of x, this is the length of 2 1, so x plus 2. X plus 2. So x plus 2 times x plus 2, we would write as x plus 2 squared is equal to -4. And technically, we just did the process for completing the square. All right, so essentially what the process is that we're making room for us to actually complete the square. And then whatever we add to complete the square, which we get by figuring out how many x bars we have, we divide that by 2 because that's how many we put on each side of our x squared. And then we just multiply it by itself or square it because that gives us the area of this little baby square here. Whatever we add, we have to add to the other side so that it keeps even, keeps balanced. All right. So let's try the one down here. So same thing. I'm going to draw a line. So ignore these 9 for right now because I'm just going to move them later. But if I just look at what I currently have right here, what is this? So what does this represent? What expression? X squared plus 6x plus 2. And it's going to be equal to 0 on the other side. So I got to make room here to complete my square. So I got to make room right here to complete my square. So what do I need to do? How do I make it so there's nothing here? Subtract the 2 to both sides. So I'm going to move this to the other side and negate it. So in other words, I'm going to subtract 2 to both sides. So this would give me x squared plus 6x, leave a big space, is equal to -2. Now, we already found out that how many squares go here? 9 squares go here. And how do we know that? Someone's besides Dylan. How do we know that 9 squares go there? 3 times 3 is 9. We have 3 bars on this side, 3 bars on this side. So in other words, we took the 6, we divided it by 2, so it's separated evenly on both sides, and then we squared it to get our mini square. Now remember, whatever we do to one side, we got to add to the other. So if I copy this and add it to the other side, it goes over 2 of the negative ones. So how many ones am I left with? 7. So if I add the 9 to both sides, I'm left with x squared plus 6x plus 9 is equal to 7. Last thing I want to do is factor this by figuring out what my side lengths are of my square. Since I have the square, I can get my side lengths. So what do you guys think my side lengths are? So think about it. What do I have to get to multiply to x squared? What has to be on this side and this side? Think box method. X. So this would be x and x. So we multiply by x by some number to get these 3x's. What do I need to multiply to go from x to 3x? So x times what gives you 3x's? 3. So this would be plus 3. What about here? X times what gives us 3x's? 3. And if we check, 3 times 3 gives us 9. So this can be rewritten as x plus 3 squared is equal to 7. And we've completed that square. So do you guys understand why I'm giving you guys this visual so that you can actually see where this stuff is coming from? It's not just a method.
Yeah.
All right. So it literally, when we say completing the square, we're literally saying we're forming a square. We're forming a shape that has 4 90-degree angles and 4 congruent sides. All right. That's literally what it means to complete a square. This is physically a square. Same thing with the one that we had at the top. It's physically a square. All right. So now what I want you guys to do is go to Delta Math and go to the assignment that says 6.2 intro. Or no, not 6.2 intro. It's completing the square practice. So it says complete the square practice. Go there. We're going to do a couple together. So we're going to do the first problem listed there. So go to Delta Math, go to complete the square practice. That's what we're going to do today. And I highly recommend you grab a sheet of paper. So guys, this is important that you know how to do this because our next lesson on circles relies heavily on this concept. All right, so I'm doing the very first problem. So find the complete the square constant. It's the very first section. And we should all have the same problem. All right, so now this question just asks us to figure out what number we would need to add to both sides to complete the square. Well, in order to figure that out, we got to figure out what our square would generally look like. Now, we're not going to do this with the algebra tiles because it'll be really big numbers. All right, but just think about what we did there to here. So if this is our current shape, all right, what would I have to do first before I can figure out how many ones I need to go in that square? So in other words, what did we do first here? Not yet. So we started out with 2 ones, but what did I do with those 2 ones? You moved them to the square left, to the other side of the equation. So, in other words, I need to move my constant to the other side. How do I move it? You add it. We're going to add 6 to both sides. Now we leave the space here and equals 6. Now, we then need to figure out what goes into this space. So think about this logically. There's 20 x's total. So if we were to place it on either of those two sides, how many would go on each part of the sides? 10. All right. So in other words, how big of a 1 square are we making? A 10 by 10. So what's 10 by 10? 100. So that's what we'll be adding here. So the formula for this is actually you take the p-value, you divide it by 2, and then you square it. All right? So that would be 20 divided by 2 squared, so that's 10 squared, or 100. And remember, whatever we add to one side, we have to do what? Add to the other to keep that balance. This will be x squared plus 20x plus 100 is equal to 106. So the answer to the question, what needs to be added to complete the square? That right there, 100. That's what we added to both sides of the equation in order to complete our square. So if you forget b over 2 squared, all you got to imagine is, okay, if I'm thinking algebra tiles, this is how many x bars I have. I got to put an equal amount on both sides to form the square. How many would that be? And that would create the size box that I need for the square. So for example, if we look back at our original problem, we started with 6 x's, all right? We had to put them evenly on two of the sides of the x squared, all right, in order to have an area to form our squares here. So 6 divided by 2 in order to make it even is 3. So we put 3 here, 3 here. That means that this little square right here would be a 3 by 3 square. Meaning if I took the area, there would be 9 little squares that could fit in there. And that's exactly what we did here. All right. If we had, let's just say the x squared, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. There's 20 x bars here, which means this space would have to be filled with 1s. And that would be, you would do 10 times 10. Does that make more sense?
Yes, ma'am.
All right, so this answer right here would be 100. So that's what we had to add to complete our square. All right.
Wait, don't I list the top right part?
Okay. So the actual formula for finding that constant is b over 2 all squared. So I would write that down because you will see it again. But that's just another way that you can think about it if you forget this formula. You can think about it as, okay, if I'm actually making a square, you're going to have an even amount on each side. There's 20 x's, so I have to have 10 on each side. That means this is going to be a 10 by 10 square. So area-wise, it's 100. All right. Am I good?
Yes, ma'am.
Yeah, you're good, sorry.
All right, we're going to do the other single, which is the third one from the top. So it's the first one that said actually finding the equation. So completing the square, even b, multiple choice, that very first one. So now we're actually going to go through the entire process. So the first one was just us finding that b over 2 squared value. Now we're going to go through the entire process to get the actual equation. All right, so let's talk through it. So before I can complete the square, I got to get rid of some stuff in order to make room for those values I want to add in. So what do I need to do first here?
Plus the 1?
Nope. Add the 3. I need to get rid of the c value. So whatever constant is over here with the quadratic, that's what you move to the other side. So I'm going to add the 3. This is x squared plus 2x, I'm gonna leave this space, is equal to 2. Now, what do you think's gonna go here in this space? 9. Dylan, there's such a thing as thinking first, so.
It's not.
It's not 9.
Now I know that. 0.
What's my, so we're doing b over 2 squared.
Sorry, you might have lost one. It's 1.
It's 1. So again, think of your square. You have 2 x's. So if you put them evenly on either side of your x squared, there'll be 1 on each side. So it'll look like this. So you'd have a 1 by 1 square, which was 1 times 1? 1. So again, this would be 2 over 2 squared, which is 1 squared, which is 1. And remember, to keep balance, whatever I add to one side, I gotta do what?
Add
Add to the other. So you can add, subtract, whatever you want to an equation as long as you do it to both sides. Alright? So this would be x squared plus 2x plus 1 is equal to 3. Now, the last step you do is factor this. So you can either do big X, so there's actually a trick. So the trick is that since we know that the side lengths are all going to be the same, because it's square, so we're going to end up with something all squared. The trick is that if you notice from our previous ones, the side length was always the square root of the first term, the square root of the last one, in just a second, and then they kept the side of the second. So if we look back at our previous problems, one side length was the square root of our first term, so the x squared, square root of x squared is x. The square root of our last term, so square root of 9 is 3, and we kept the sign of the second term. So since these are positive, you keep it as a plus. And that's what transfers here. So this would be x plus 1 all squared. And remember, this is the same thing as x plus 1 times x plus 1. And that's our answer.
Some water.
So this one right here will be what we click. You need something.
There's a cheese stick on the floor. I kind of like flung from back here and then hit me in the middle of the floor. I don't really know, like, I can't really like tell you where it came from.
I know throwing cheese in here. This ain't Wisconsin.
That is disgusting.
Bro, Tyler, shut up.
Layla, why would you throw a cheese stick at yourself?
Okay, so here's what we're gonna do now.
They're gonna write
That's
things.
a point.
5 minute break. Green's like the 5 minutes.
Y'all shut up, I tell you.
I love big cheese.
Are we going outside, Miss Harvey? No.
What is that comes from?
Okay, can you guys shut up?
So, I'm gonna give you your 3-minute break. Don't move yet. When we come back, I'm gonna give you 15 minutes to finish the rest of this delta math. It's only 4 problems per those last 2 sections. There's 8 problems. Goes just like the 2 that we just did. All right, so it shouldn't take you very long. And then after that, we'll go into our lesson for today. That's pretty quick. All right, so go ahead and take your 3-minute break, and then we'll come back.
3 minutes or 30 minutes?
3.
Dylan, for you, it's 30 seconds.
I'm not talking about the break, I'm talking about the delta math.
I said 15.
Oh.
Can I get started?
If you want to, yeah. You want to go ahead and get started on your break. Off the phone, Jack.
Sorry, somebody was texting me.
I'm gonna ask you, I will let you do it. Yeah, they're reviewing between the squares. So it's always fun.
We're just having.
Jackson.
Yeah, Julian's gonna crack.
He's like, this is how he walks. He's man, he just walks it on the lawn. We're giving you props for walking like that.
Says the girl that threw walk like that. Says the girl that threw a cheesesteak at herself.
Man, I didn't do anything. I'm just sitting.
Dylan, you're a
cheese toast to get.
Yo, why are you calling your students?
They look your favorite student by far.
Yeah.
100%. Don't even lie. Yes, you do.
And you're one of them.
Oh man, oh really? Like really?
They said it. Take that.
There's really not all
Dylan, I do it with love. You clearly what? All right, guys. Okay, so never a dull moment. I'll say that. All right, so I'm gonna give you guys 15 minutes to work on those last two sections, and then we will move on to our lesson. But I want you guys to get pretty decent at completing the square first, because again, this lesson we're about to go into relies pretty heavily on it. Yes.
7.5.
Can we get 20, please?
Yeah, can we get 20?
It's actually really hard. That's what I'm trying my best right now.
It's not hard. It's 15 minutes.
Oh my God.
17. I'll settle.
Miss Murphy,
We'll
everyone.
settle for 15 and like it.
Miss Murphy, are you gonna miss us next semester?
No.
Definitely not, bro. Definitely not.
It's gonna be happy.
Especially.
Gotta get to work. 5 o'clock ticking.
You should give me an extra
The more you
15.
get done now, the less you have for homework.
Oh my gosh, I forgot to do the thing last night, Miss Murphy.
Well, you're really smart, aren't you?
Stop. I went home. I went to bed.
So for y'all's convenience, I'll write the actual steps for completing this round on the board.
Clock sticking, Miss Murphy. Yeah, Jules. Yeah, Jules. You guys hold hands over there?
Dylan, shut up.
Dylan, you actually doing your work over there?
Oh.
Yeah, I'm done.
Can we stop bullying Dylan, please? Like, you guys What's on Terry?
The tire's right there.
What?
She wants to talk.
I never done that.
Oh, wow, that's crazy, bro. That's disrespectful.
I'm trying to do my work.
Hey, Terry, I'm sorry about that.
No, I'm just trying to do.
Y'all, would all of you just hush and do your work?
Yes, ma'am.
Thank you, Miss
Yes, ma'am.
Murphy.
Like, I really like need to. I'm gonna look at the steps.
Bruh, Dylan.
Thanks.
That was so mean of me. Say you're sorry.
So disrespectful.
All y'all, shut up. Like, I'm at this point where shut up. Let your top lip meet your bottom lip and let it stay there.
Miss Murphy, can you do that EOC for me, please?
Can I do the EOC for you?
Yeah.
Yeah, I don't think anyone believed that.
Is this a state mandated exam?
Yep. 25% your final grade.
Is there any way to get out of it?
Nope.
What if I have like a heart attack?
They just make you take it next year.
Yeah, bro, you really want me in this class?
Yeah, let's think of the probability.
It's heavily curved.
Hey, Miss Murphy, when are you
Oh,
gonna
Miss
start
Murphy, I need that,
decorating?
please. I need like a 50% curve, please.
Miss Murphy, when are you gonna decorate for Christmas?
Until December.
Oh, man.
We do like Thanksgiving bath bombs. Like,
Can I be the elf on the show?
I'm not gonna say anything to that.
Wow,
Too
that's very
easy.
rude, Miss Murphy.
Too easy.
You can fund your students
No,
again.
no. I want
Dylan just sets himself up. Okay.
That's what I would say.
Does it have an off switch?
Stop. That's great. Stop.
I got you.
No, it's not.
Miss Murphy. My math teacher called you Miss
They
Murphy.
won't you.
You got too much hair to be opinion.
Miss Murphy, can Tyree move his cheese? Start smelling.
Someone pick up the freaking cheese.
Bro, I don't have it.
I don't care whose cheese it is. Someone pick it up.
It's my roots. I really want to throw it.
Thank you.
Yo, grab it after. Please grab it after. Please grab it after.
Oh, no, that's
You should eat it. I'll give you $20.
Yo, I'll give you $20 right now.
Guys, this isn't like a diary when we kid. You gotta eat the street cheese.
Here we go.
He has the cheese touch. No, where did it go?
I'm gonna throw it away. I'm gonna put it in a bigger person.
Is it funny, Joe?
Did we all see that?
Now I understand why your girls' grades are like this. Okay.
Hey, not all of ours. There's some.
I think it's just down to
Just a little.
Like Lainey, she's such a smart person. She's actually very hardworking.
Yeah. Do your work.
I'm not good at math.
Dylan, wow. Exactly. Be quiet.
You know what cough is? Like the kind
Nobody
of
has
thing.
got to cough that much. Exactly. I think you're doing
I might just be sick with use your head.
You're black.
That's not
Again, y'all.
That's a bad word.
Again, y'all.
Please,
Again,
be
y'all.
nice.
Again, y'all. Shut up.
Greek.
Yeah.
Let's figure out.
Hey, Miss Murphy.
Get it for
Can I read it?
I like the way you
Miss Murphy.
Mm-hmm.
No.
Hold on.
What's your problem, Dylan?
Hey, you got a problem over there?
You know, y'all, the trick to, actually being successful is just not to engage. Just let it go. Let it go.
Excuse me.
Guys, I'm like 5 seconds away from making y'all not talk at all. And taking it for a quiz grade. Get your work done.
We're good students.
Okay.
Maybe even great.
I asked first.
Okay, I should go first.
I just need help getting this started.
Well, you just gotta
Because I don't know how to do this.
Oh, when you take
I don't know, I have to do it. I know. This one's right
Yeah.
This one, it says, I text her.
And then square it. So
Why did you launch it to
yeah.
I love
fraction,
you.
Right.
Hey, just blame it on Frederick.
Hold on. Start the blame game.
It's not this
By the way, y'all, your test grades are in from yesterday.
Ooh, let me look at this.
Yeah, I definitely got a 0.
Should we get a curve rating, please?
No.
Why would you say no to a curve?
Okay, we're all-
A 62. Let's go, Miss Ruby. That ain't even bad.
That was curved.
Oh. You have a 49 curve.
What did you get, Dylan?
Bro,
A 62.
I got a 62. Why are you grading like I slimed your mom?
It was curved.
Curve it more, please.
Nope.
Please stop to like a 7.
Yeah.
You need to pass the curve. Anybody get a 70?
I had some 90s.
No way.
In this class?
Serious?
Uh-huh.
No
It was
way.
her. It was definitely her. You? I don't think they was in this class. Jackson
way.
did not get a 92.
Probably cheated.
Jackson cheated.
Highest in this class was an 85, but I had some 90s in my second period. Same test.
Well, maybe they're just cooler than us.
These trusses curved.
Yeah, that's curved.
What'd you get, Reggie? Freddie?
I mean, if y'all want to know your raw scores, I got them.
No, say them out loud.
I wanna
Come on,
know
let's go. I want to know mine. You can say it out loud.
Okay. Dylan, 45.
That is not.
45.
Oh my.
Please say Wyatt. Please say Wyatt.
Please don't say mine.
See why.
What did I get? I'm curious.
And my grade didn't show
Wait, why? What was your grade?
up. Might have been on fast test. I don't know. I was kind of.
It's
Unit-
5 test.
Well, I'm not really on a 63.
Jordan's coming to
Let's go. Why are you on airport? 62.
What?
You did not get a 90.
Alright, you got a 65 curve, so 49 without the curve.
Who got an 85 in this class?
I have a
79. Still did pretty good.
Dylan, I got a 65. I'm smarter than you.
I got a 60.
That's just not how that works.
Guys, I only got like 5 minutes until we're moving on.
Sir, we need more time, please.
Nope.
Please.
Maybe I shouldn't have been talking.
I'd say like 25 more minutes is sufficient.
Nope.
I can use a good vocab word.
Nope.
Please.
Nope.
Please.
Nope.
Miss Murphy, are we ever gonna go outside?
Nope.
Hey.
Please.
Nope.
Please.
You can say it as much as you want. Answer still no.
Are we more favored than your second period?
No.
She said no. Second period's your favorite.
Oh, she hates us.
I don't hate y'all.
I think she only likes Layla.
Yeah.
Layla and her like.
Julian likes letters too.
Julian, is that true?
Y'all, do your work.
Yeah, he said he was gonna crack for
Julian did. Hey,
Y'all, this ain't freaking Tinder. Get to work.
Are you on Tinder?
No.
Why would you ask that?
What? Sorry.
Brother, she said you're still there, bro.
What if the teacher's like, what is this?
Julian, are you on Tinder?
No, I'm not on Tinder, bro.
No,
we
he
got
has
work.
Yeah,
You have 3 minutes.
I did my work.
Probably not doing one.
I'm doing my work.
Layla, you
What, you're
finished?
cheating with that phone right there?
I'm not cheating.
Mm-hmm.
There's no phone there. Tyreek never pulls out his phone. He's a great student.
Tyreek.
Trust it from a reliable person. Miss
Julian,
Murphy.
get your girl.
Oh my god.
So if I look at y'all's grades right now,
I have a 55, but that's just because I haven't done the Delta maths yet.
What's the highest grade in the class?
So if I look at these current Delta Math grades,
I just have a lot of zeros on Delta maths. So everything else
1, 2, 2 people haven't even started.
I got one done.
1.
Are you proud of me?
No.
Oh.
Oh, she hates us. Confirmed, guys.
You could have gotten all of them done. I have a couple of hundreds already. I mean, they already finished.
Is B the X?
Yeah.
Miss Murphy, but there's nothing to like go to the other side on this one. So do I just not do that?
It's only asking for you to find what you're using to complete the square. So you just do b over 2 all squared.
B over 2 all squared.
Mm-hmm. So you take the b value,
So negative
divide.
17 over 2 squared.
Uh-huh. So that'll be 17 squared over 2 squared.
17 squared over 2 squared.
289 over 4.
You
You're not tough.
can do that in your head, Miss Murphy?
I can go up to 20 with perfect squares. Actually higher than that, but
Miss Murphy, do you think you're like basically raising some mathematicians in this class? Do you think we're gonna be like you? You think we're gonna be a math teacher?
I mean, if y'all are,
We are definitely getting paid like $5,000 per hour. For a
I
math
am not being a teacher.
We could not be a math teacher.
I'm trying to feed my family, not myself. Uh-oh.
Think it needs to be set for another 15 minutes.
all right, guys. So go ahead. You can finish it later. Go ahead and close your Chromebooks. Take out your packet. Go to page 5.
How many more units do we got, Miss Murphy?
This is unit 6. There's 9 total.
Wait, we might finish before the end of the term.
No, it's 3 per term. Trust me, it'll get close.
Wait, how many weeks are we into this term?
I think we only got like 2 more weeks until grades are due again.
And
Yeah, it's like right
how have we,
before-
how have we
It's like right
done-
before Thanksgiving, yeah.
How have we done 2 units already?
Because those units were particularly short.
This one's long?
This one has a lot going on with it.
Thank you for the curve, Miss Murphy. I don't know if anyone said that.
Yeah, just for actually thank you for that.
You
Without
save our
that.
grades every time.
What?
You save our grades every time.
I mean, I do it based off of how y'all did originally.
Which is horrible.
Thank you, Miss Murphy.
Not necessarily horrible. I could have left them as they were. They would have been able to pop back because I do give you guys test corrections too.
Thank you, Ms. Murphy.
So-
Those are so hard.
Test corrections? You can use your notes on them.
My class teacher in my F1 was math because we could not understand anything. Okay, guys, I know that sounds a little racist, but it's.
I don't see that on test.
He was like talking weird, which was hard to understand him, so he just messed up.
That was like half my college professors. Like they all came from different countries, so they all had accents.
That's what I
We'll be like, I think it was all like.
All right, guys. So, shh. So basically, what we're talking about today is yesterday we talked about the standard form of a circle. 5.
Oh, we're on 5. I mean, she just said that.
Oh, I thought we were on 3.
So, yesterday we learned about the standard form of a circle, which is that x minus h squared plus y minus k squared equals r squared. Now we're going to look at what to do when it's not in the standard form and we need to convert it to standard form, because standard form is the only one that will give us our center and radius right off the bat. And honestly, those two are probably the most important pieces of a circle because it tells a lot. It tells us how to actually make the circle. So standard form is this. So this is the standard form of a circle. And remember, the center is equal to HK. Stop throwing stuff. And the radius is equal to R. So, quick review from yesterday. If we're looking at the equation of a circle, and I asked you what the center and the radius is, what's the center of A?
Negative x, wait, -1.
No.
-1. Wait, x minus 1.
So the first one, it gave you the equation. What's the center?
0.
0, 0. What's the radius? 10.
0, 0.
Because there's nothing being added or subtracted to it, so it's 0.
There's always a 1 in front of x.
But we're talking about subtraction and addition. If it was multiplication, it'd be 1. But we're talking about subtraction addition, so 0. All right. What's my center for letter B? 5, 2. What's the radius? Good. So remember, you just take the square root of whatever it's equal to get the radius. And then you flip the signs. And you flip the signs of what it is in the center to get the center. All right, last one. Good. What's the radius? Good. All right, so that's just a review from yesterday. Now, quick review of completing the square. So, when it's not in standard form, it's really difficult to find the center and the radius. And remember, if we were asked to graph the circle, we need that center and radius to give us a general idea of what the graph looks like. So we have to use completing the square. So in reality, we would just be completing the square twice instead of once, all right, within the same problem. But let's review how to complete the square first. So I highly recommend on somewhere on your packet writing those notes that I wrote on the board. All right, so I highly recommend writing that down because that's the general notes. But look on the board, board 1. I wrote down the steps. Yeah. So let's just go through this. So first things first, step 1, I got to move the constant to the other side. So what's my constant or C value?
-39.
-39, right. Because if I have y equals, or actually it's more like, if I have ax squared plus bx plus c is equal to 0, I'm talking about the value that's not connected to a variable. So how do I move the -39? Add it to both sides. So I'm then going to write x squared plus 10x, leave a space so I know I got to fill something there. And it's going to be equal to 39. Now, we then go through the actual completing the square process, which that's when you do b over 2 all squared. So what's my b value?
10.
It's 10, so I do 10 divided by 2, and I square it. So it's 5 squared, which is 25. So I'm going to add 25 here. Now, what did I say I have to do to keep the equations balanced? If I do it to one side, I got to add to the other. So that's the biggest step that most people miss. They forget to add to the other side. All right? So this would be x squared plus 10x plus 25 is equal to 64. Now, the last step is to factor the trinomial on the left side of the equation. So you can either do big X, you just got to remember to put it into the form of whatever the binomial is squared, because you should get the same binomial twice if you did big X. However, there is actually a trick that can save you time and not have to do big X. So the trick is that you would square the first term, or not square root, it's not square root. So you'd square root the first term, square root the last term, and those will give you the two numbers that go in your parentheses. And then you would separate them by the sign of the second. So what's the square root of x squared? X. Bring down the plus. What's the square root of 25? 5. So you have x plus 5 all squared, and it's equal to 64. And this is where we can stop when we come to completing the square. So in math 2, you would go a step further and either solve for x, or you would subtract the 64 back over to get the vertex form of the quadratic. But for what we need, we can stop right here. That's as far as you need to go. So once you factor, you're done. All right, any questions? All right, let's try letter B. So what's my first step? What about it? I gotta add the constant to both sides to get rid of it. I gotta make room for what I'm gonna complete the square with. So this be x squared minus 6x. Leave that space so I know I gotta fill it. You don't have to draw the space, but I like to do it just so I remember that I have something, that something has to go there. And it's equal to 7. How do I get what goes in the space? So do b over 2, so negative 6 over 2, and square it. So that'll be negative 3 squared, which is what? So if we add 9 to one side, what am I missing? Add 9 to the 7 on the other side. So this will be x squared minus 6x plus 9 is equal to 16. My last step is to do the factoring. So I would square the first, keep the sign of the second, square the last. So what's my binomial? X minus, what's the square root of 9? 3 squared. And it's equal to 16. So remember, square root the first term, keep the sign of the second term, square root the last term, and you write it in that order. And then you just make sure you square it. And then we're done. Now, to find the equation of the circle, we're pretty much going to do that exact same method again, but we're going to do it twice in one problem. So you're going to do it for the x's and you're going to do it for the y's. All right. So, again, you're going to complete this process by completing the square twice. So first, if we look at this equation right here, we first need to ask ourselves, okay, are the x's and y's together? So x's with x's, y's with y's, are they together? In other words, we're side by side. Yeah. All right, so the x's are with the x's, the y's are with the y's. We don't need to rearrange. Are there any constants on the left side that I need to move over? No. So we can go straight into the completing the square process. So what I do is I just rewrite this entire thing. So I rewrite it as x squared minus 4x, leave a space, plus y squared minus 8y, leave a space, and it's going to be equal to 5. So I'm going to complete the square for the x's. I'm going to complete the squares for the y's. So whatever I put into these two spaces are going to get added to the other side. All right, so you're going to add 2 numbers to the other side, not just 1. So if I do negative b over 2a for the x's, so what's my b value? Not just 4, but negative 4. So I divide negative 4 by 2. So that gives me negative 2 squared, which is what? So I'm going to add 4 here. So that means I also need to add 4 to the other side. Now, what about the y's? What's my b value? Negative 8. So divide that by 2 and square it. So this would be negative 4 squared, so 16. So I would add 16 here. Remember, whatever I do on one side, I got to add to the other. So if I rewrite this, I have x squared minus 4x plus 4 plus y squared minus 8y plus 16 is equal to 5 plus 4 is 9 plus 16 is 25. Now, if it helps you with separation, put the x's in parentheses and put the y's in parentheses just so you have that separation. You know you're just going to factor them separately. All right, so I'm going to factor each perfect square trinomial separately. So I'm going to square root the first and the last of the x's, keep the sign of the second. So what would it be as my binomial? So what's the square root of x squared? X. Bring down the minus. What's the square root of 4? 2. And then what am I missing? What am I missing?
25. 60.
What goes up here? A square. Plus, all right, square root the first, keep the sign of the second, square root the last. So what's the square root of y squared? Bring down the minus, square root of 16. What am I missing?
25.
The square. Now I bring down the 25. Now, what does this look like to you? What's that I just circled?
Yeah.
The answer.
But what does it look like?
Our center and radius.
It looks like the equation of the circle. So in other words, that's how we can get our center and our radius. Good. So what is my center and radius? So center is 2, 4. What's the radius?
5.
Good. So if we were to graph the circle, now if you hand graph a circle, just get as best you can. So you always start by graphing the center. So we go 2 and then up 4. Now, the radius, unlike in delta math where you only had to move it one time and it just did it automatically, when you're doing it by hand, I just say go in all 4 cardinal directions, so north, south, east, west. So go 5 to the left, 5 to the right, 5 up, 5 down. All right, so it gives you an idea of where the circle's going to go. So I'm going to count 5 east, so that's to the right, 5 north, so that's up, 5 west, so that's to the left. That was 4. And 5 south, so that's down. So your circle should go through each one of those points. So then you can just draw it the best you can. So don't connect them per se. You just kind of draw the circle that goes through all 4 of those points. It doesn't have to be pretty. Just get it as best you can. God help, I can never. So all those points do is they just give you a reference of what points your circle is going to go through. So you can get it as close as possible. All right, any questions on that one? So again, if you got to hand draw it, just do a compass for the radius. So north, south, east, west, that's where you should have a point for each. All right, so let's try some more examples. So let's look at letter B on the next page. Yeah, because it's really similar to the one we just did, like similar numbers. All right, so first off, when I'm looking at B, I need to ask myself, are my x's with my x's or my y's with my y's?
Yes.
Yes, so the x's are next to x's, the y's are next to y's. Do I have any constants on the left side that I need to move over? No. So I can go right into my completing the squares. So I'm going to rewrite this as x squared minus 18x, leave a space, plus y squared minus 10y, leave a space. It's equal to negative 6. Now, if it helps you, you can put parentheses around both of these just so you know that the x's and y's have clear separation and we're doing them individually. All right? So for my x's, in order to complete my square, what do I do? Right, do negative 18 divided by 2 and then square it. So what's negative 18 divided by 2? Negative 18 divided by 2 is not 81. It's negative 9. Square it, then it's 81. So I'm going to add 81 here. Which means what do I have to do the other side? Add 81. What about my y's? So what is it? So negative 10 divided by 2, square it. That'll be negative 5 squared, which is 25. So I'd add 25 here and where?
You added
2.
81 and 6.
So I add to the other side. Do not forget to add it to the other side. You got to keep your equations balanced. So if I rewrite it, I have x squared minus 18x plus 81 plus y squared minus 10y plus 25 is equal to 100. Well, let's see. 81 plus 25 is 106 minus 600. Yeah. All right. What's my last step? Factor both of them separately. So remember, take the square root of the first, keep the sign of the second, square root of the last. So what's my binomial for the x's? X minus 9. What am I missing? Do not forget that square. It's part of the formula. Plus. So if I do the y's, it would be y minus square root of 25 is 5 squared, and you bring down the 100. So what would the center be? 9, 5. What would the radius be? 10. All right, one more and then we're done for today.
Let's do this one fast.
I don't think you want to do this one fast.
Oh.
Look at letter D. So with letter D, first off, are my x's with my x's, my y's with my y's? Yes. Are there any constants I need to move to the other side? 260. How do I move it? Subtract it. So we're going to subtract 260 to the other side. So I have 5x squared minus 70x plus 5y minus 20y is equal to negative 260. Now, here's the problem. My a values for both have to be 1. So in other words, I can't have a constant in front of it. So how do you think I'm going to take care of that?
You divide by 5.
I can take a GCF of 5 out, so factor a 5 out. So if I factor all 4 of those terms out by 5, I'm left with x squared. What's negative 70 divided by 5?
14.
Negative 14x plus y squared minus 4y, and it's still equal to negative 260. Now, when we finish our equation of the circle, it can't have anything being multiplied on the outside to it. So how do you think I'm going to take care of this 5?
Get rid of it.
How?
Times it.
Nope.
Square root it.
Nope.
Divide it.
Yes, because we're multiplying it, so the opposite of multiplication is division. So this would be x squared minus 14x, and I'm going to go ahead and leave my space, plus y squared minus 4y, leave my space, and that's equal to 52.
Nice.
All right, so now we're in complete the square mode. So that's how you get rid of those constants. You need to find the GCF of both, factor it out, and then divide it to the other side. All right. So it also gives you smaller numbers to play with. So what's my negative b over 2 squared for the x's? So if I do negative 14 divided by 2, square it, that'd be negative 7 squared, which is 49. So I'm going to add 49 to both sides. What about the second one? Someone besides Dylan. So what about the y's?
2, 4.
So negative 4 divided by 2 is negative 2. But if you square it, what would it be? 4. So this would be plus 4 to both. So this would be x squared minus 14x plus 49 plus y squared minus 4y plus 4 is equal to 1. And again, you can put these in parentheses if you want that separation. What's my last step? So factor. So square root the first, keep the sign of the second, square root the last. So what's my binomial for the x's? X minus 7 all squared plus
Y minus 2 squared.
y minus 2 all squared, and it's equal to 1. So that's my equation of the circle. So what is my center? 7, 2. What's my radius? 1. Any questions on how this works? It's not too bad, honestly. If you're decent at completing the square, it's actually not hard.
It's very future math major here.
You want to see some of my homework from college?
Yeah.
It'll make you cry. All right. Like, I'm not kidding. It's something. One problem for me would be like 3 pages, front and back. Like, that's some proofs that I had to do.
300? Oh,
3 pages, front and back. 3 pages. All right. So, all right. So that's it for today. So your assignment, and you guys got a solid 15 minutes? Nope. Your assignment, there's a 6.1, 6.2 delta math that covers what we did today and yesterday, and you also need to finish that completing the square delta math if you did not do so already. It's a classwork grade.
So you
That was so